Intro to Parametric Equations. Parametric equations provide an alternate way of drawing a graph by introducing a third variable into the mix called the parameter. Let's take a look at an example problem. So I have a pair of what are called parametric equations here. This pair of equations will generate just a single graph. Normally, when we go to draw a graph, we have an equation that links up x and y. But when you use parametric equations, you introduce this third variable t. Notice that in the equations, x is being linked to t, and y is also being linked to t, instead of x and y being linked to each other. How am I going to create some points for my graph? Well, I will assign various values to t, and then because of these equations, I can plug those values in to generate corresponding values of x and y. X, it says, is the t value minus 3. So just subtract 3 from each of these t values. And then, let's see, the y is the double of the t. So simply double all those t values. Well, look what's happened now. Each t value has generated an xy ordered pair. These are the ordered pairs that I'm about to graph on that xy plane there in order to generate the picture. So this is still the xy plane. Looks like I need x values going out to -3. I'm going to need some y values that go to 6. And then I can plot my ordered pairs. So -3, 0, -2, 2, -1, 4, and 0, 6. And it turns out these particular parametric equations have generated this line in the xy plane. Each point on the line does correspond to a particular t value. Here was t equals 0, t equals 1, t equals 2, t equals 3. In fact, sometimes what we'll do is we'll put an arrow onto the picture to show the direction in which the points were formed following t order. In this way, the t provides some additional information to the picture. For example, maybe in an application problem, t stands for time. And so I have an object moving along this line, and t tells me when the object is there. So first I have the beginning, and then after 1 second and 2 seconds and 3 seconds. Notice that the addition of that parameter then gives me more information that I would normally have when I draw such a line. Well, the graphing calculator can be used to graph parametric equations. Let me show you how that works. The first thing I need to do is change the mode on the calculator. So I'm going to go to the mode button. Normally, we are in function mode, which is right here. I need to arrow over and then hit enter to change the calculator to parametric mode. Don't forget to change it back when you're done. Notice now when I go to the y equals area, everything looks different, and the calculator is now set up for me to type in that pair of parametric equations. Our example was x equals t minus 3. The t button is the same as the x button here, so t take away 3. The second equation was 2t. And then I do need to go to the window button and specify what values of t, x, and y I want to look at. To match what we did on the paper, we had picked t values from 0 down to 3. Now, the t step number is what the calculator is going to count by. And in this particular example, I don't think it'll matter very much. I'll go ahead and say count by ones, just like we did on our table. In later examples, we'll need to count by something a little smaller to see an accurate graph. Let's see, on our picture, we went down to about -3 on the x-axis. I'll go to +3 just to have a little bit of symmetry here. I'll count by ones, and then on the y-axis, I don't think we had anything below 0. We went up to 6. I'll just use -6 to 6 again just to see kind of a full picture here. And then when I hit graph, the calculator will draw the graph, and of course you can see I have the same thing that we got on the paper. If I use the trace button, notice that I'm given a little bit more information than what I'm used to. I'm given the x and y coordinates, but I'm also given the value of t. And if I arrow through the line, you see there's when t equals 1 and I'm at the point 2 comma 2, or when t is 2 and I'm at the point negative 1 comma 4. If you want to see more points, you'd have to change that value for t that we were counting by. Sometimes it's possible to take the parametric equations and convert them to a standard rectangular equation, meaning an equation with just x and y. It must be possible here because we know we can come up with equations of lines in the xy plane. How would we do that? Well, it's basically just a matter of eliminating the t, if at all possible. For example, what I could do is I could take that top equation and I could isolate the t. I could do that pretty easily by just adding 3 to both sides. So that would become t equals x plus 3. And then I could just make a substitution. In other words, I could go to the second equation, and in place of the t, I could write down this new name for t, namely x plus 3. If I clean that up, then I have the equation of that line. This is just the line y equals 2x plus 6. You might remember from algebra, this means the y-intercept of the line is 6, which matches our picture, and the slope of the line is 2, meaning it goes up 2 over 1, up 2 over 1, and again, that matches our picture as well. This equation generates the same graph as these two parametric equations, but the parametric equations do provide a little bit more information. We had that time element, which tells me when I'm at each location. The rectangular equation can only tell me about the locations themselves. Thanks for watching.